Hello, everyone. Today we're going to cover chapter um, five, dealing with estimations. Dealing with estimations. So before we jump in estimation, a couple of things to understand when it comes to engineering in regards to estimation. Well, as engineers, we don't do a lot of estimating, but what we do is we make engineering assumptions, right? And in certain situations or certain problems, depending on what discipline of engineering you're in, seeing that I'm a mechanical, I usually refer to, mechanical things. And I work with chokes. I don't know if I spoke about that. Maybe I think I did during my introduction. I can't remember. It doesn't really matter. But anyways, you're making engineering assumptions. Um, will this material work for you? Uh, this material work for you for this application? If you're designing something, right? So if I'm designing a choke, the biggest focus is um, pressure, right? Pressure. Will it be able to handle this amount of pressure? And the materials within that particular choke, will it last for whatever fluid you're flowing through that choke, right? So materials is really big. And we make engineering assumptions based on what you know to have happened in the past, right? What happened in the past? Well, back in the day, we used this material and for this application, for this fluid. So I can make an engineering assumption that it is repeatable. I can do it again, right? Based on calculations that I made or that were made prior to me designing something new, right? The calculations were accurate for this pressure, for using it to this pressure, for using it again and again. That you're making an engineering assumption that it's repeatable, but it's not based on just you're just thinking of it out of the blue, right? That's not what it is based upon. It is based upon it actually being tested or it has actually been done before. Now, what you can't assume is that if you took this and put it in a different climate that it has never been in before, and it will work the same way, right? That's not making an engineering assumption. That's just making an assumption. And you know what that means, right? If you break up that word and talk it out, making a out of you and me. But anywho, that's not what we're doing here. And that's not how we want to approach this particular section. There are multiple ways for making an engineering assumption, and I just gave you one is comparing. And comparing is making an engineering assumption by analogy, right? Making an engineering assumption by analogy, which is you compare something that has happened that has happened prior, and whatever it is that you're doing currently, if it's similar, then it is okay to make that comparison and assume or estimate that it will work the same way because of the same conditions. Material you're going to be using is the same. The pressure is the same. The temperature is the same. And so that is a way of making an estimation uh, by analogy, right? And what that means is we can go over other examples. That means is I don't like 5.2, but let's look at 5.3. Using estimation, doing an estimate by analogy, right? So estimate the size of an acre. I did it again, guys. I did it again. I did it again. I know you're like, man, can't you just change your setting? Yeah, I can't. I can't change my setting. I've looked and maybe I can, I'm just not there yet. Um, there you go. We gotta have the closed caption on, to help, provide learning to everyone, all types of, abilities, right? So this is one. Closed caption is is a way to provide learning to people with those abilities. All right. Anywho, so let's look at example 3. This is estimation by analogy. All right. It says, example 5.3, it says estimate the size of an acre and a hectare of land using analogy. Right. An American football field playing area is roughly 300 feet by 160 feet, approximately 50,000 square feet. That's a lot. An acre is 43,560 square feet. Using this data, we have a better sense of how much land an acre is. This is roughly 90% the size of a football field, an American football field, that is. Soccer fields are larger. Yeah, soccer fields are much larger, but vary in size. The largest soccer field that satisfies international guidelines would be about 2 acres. A hectare is approximately 10,000 square meters. This is good. And it is equivalent to 108,000 square feet. So that's roughly 2 football fields, right? And so when you're doing the comparison, somebody asks you something, so, well, what is a hectare, of land, of what have you? A hectare of land is roughly 10,000 square meters, or approximately 108,000 square feet, which is estimating about 2 football fields. And that's what estimation is. It is using various type of processes to estimate will something work. Now, do you want to design off of an estimate? No, but you want to do some calculations, right? You want to do some testing. You want to do experimenting, right? But estimating gives you a ballpark of how something will work, correlation rather, how it will work if you are designing something that is similar to something that has been designed in the past, right? Other forms of, estimating, aggregation. And I like this one because I do this a lot. I do it a lot when I'm in a building. Aggregation, performing an estimation by aggregation. Like if I'm in a building, I usually count the chairs on my row. And then I make an engineering assumption that each row has the same amount of chairs as my row, right? And so then I count the number of rows in my section. And then I assume that each section has the same amount of rows, right? And so count the rows in my section, I multiply I'll count the number of chairs in my row, I'll multiply them by the number of rows in my section, and then I'll multiply the number of sections times the number of rows times the number of chairs in my section, right? To get an estimate of how many chairs are in this building, right? How many seats or how many people can fit inside of this building based on that. And that is aggregation. That is using an estimate of quantities, right, in multiplication to make an engineering estimation on how many people can fit inside of this building, right? And that's another way of estimating, or or coming up with an estimation rather. And so in that, right, these are the 3 main focuses that you want to make sure you're doing. It is accurate, your estimations are accurate, that your estimations are repeatable, and then precision. The combinations of accuracy and repeatability reflect the number of significant figures reported. Significant figures, which brings me to significant digits. Let's look at that. Let's look at significant digits, because in a lot of cases, Make sure. All righty. So significant figures, right? A lot of times we get significant figures mixed up. Because how many digits or are significant? Like if we look at the standard, we have 55. So how many digits are significant? You know, one or two, right? 0.0036. How many digits are significant? 870020. How many are significant? 7. How many? So 2, right? Here it would be 2, 3, 4. Would it be 5 or would it be 4? It would be 4. Here you have 6. One is 1 here, and then you have 2 here. But what about if I put it 5.5 times 10 to the 1? How many digits are significant? Right? Still 2, right? But what about here 55 times 10 to the 0? Or 5.5 times e to the 1, e to the power of e to 1? How many are significant? All right. Now, what if it's right here, 7 times 10 to the 10, but what if I put 7.0 times 10 to the 0? How many digits are significant? 7.0. It would still be 1. Now, if it was 70, now it would be 2, right? But a lot of times we confuse the number of significant digits. But I don't see it here. Like, 90. I didn't even see that at the bottom. See if I can find it. Because there's one case where it could be just multiple significant digits. And it could be different. It could be 2, it could be 4. And in those cases, you would put undetermined. Here it is. Give me a minute. Okay, so share my board. So you're looking at significant figures. So like if we have 70, right? And I said, well, we have 2, but is it 2? Yes, it could be 2. But what if I wrote it 7.0 times 10 to the 1? How many significant digits? Is it 2 or is it 1? Well, it would be 1 here, right? It would be 2 here, right? So then what would the answer be? It could be both 2 and 1. So the answer would be unknown. The answer would be unknown because it's both, right? It's both 2 and 1. And so you're either going to add, say, 2 and 1, or you're going to write unknown. So the same as this one. If I were to have 220, right? Now, if I have 221, then obviously it's going to be 3. It's going to be 3 every time, no matter how I write it. But 220, if I move the decimal place over twice, it's going to be 2.2 times 10 to the second. Just 2 significant digits, 3 and 2, right? Answer again, unknown. So same as if I had 2,200, right? Same thing. You have 4. It's either 4 or 2, right? And so with that being said, you would always put unknown as far as significant digits, or you would say 4 or 2, depending on how you write it. And since that 4 or 2 and it's written out as 2200, the assumption is to engineering assumption or engineering estimation is to say it is unknown. All right, and that's significant digits. And these are, share my screen again. These are different forms of how we write things. You have your standard, you have your scientific, you have engineering, and then you have your calculator. And I'm pretty sure you all know that E is a coefficient that is representative of the power of 10, right? It's representative of the power of 10. So 5.5 times 10 to the 1 is equivalent to 5.5 E to the 1. And there are some things that you don't do, right? You never make E a coefficient. I'm sorry, not a so. You never make E as a subscript. Like you would do 10 to a subscript, you would never do E to the subscript because it's already representing that as a subscript. The 1 E1 is a subscript. And so you would never make it an E to the power of 1. You would just go E1. All right. What else to cover in this chapter? We talked about aggregation, talked about analogy, talked about digits, reasonableness. We sort of covered that. Yeah, I think we covered the big stuff. So the next thing that you would need to do is really just read over certain sections to get more information on estimation. But the biggest things have been covered. And so we'll see you chapter 6. Thanks for listening.